So we move on to the next objective, which is what does it mean for a statistic to be resistant? So I have a small example here of Joe's test scores, and I want to remind everybody how to find these, and if you're following along in Excel, it will be a requirement anyway. Ooh, this is not good. This says sheet 1. Well, that's no good. I'm going to double click down there. That was 3.1 example 1. Since I'm going to have to submit this for credit to my instructor, I might as well make sure that everything's clearly labeled and highlighted. So this is 3.1 example 3 that we're working on right now. Actually, to be fair, I think that was examples 1 and 2. Let me go back. 3.1 examples 1 and 2. There we go. Now we're on 3.1 example 3. So let me type Joe's test scores. Oh, if I could type. Oh my goodness. All right, let me double click and make that a little wider. I'm going to zoom in so you can see better. You don't have to zoom in. All right, his test scores were 88, 90, 24, 96, 88, 80. So let's remind ourselves, how do we find the mean? Okay, so the mean, and again, always want to label, is equal to average A2 colon A7 in this case. You can see how it highlights it in blue, see that? And those numbers are in blue. It's telling you where that data set's coming from. Enter. The median is equal to, median is its own formula, left parentheses, those data values. Again, it's in blue. And I'll highlight these, bold them, make this one paint bucket green, make this one paint bucket yellow, make it whatever color you like. Okay, so we found the mean and the median, and I already typed those in. Again, I lost a whole set of videos. So there's the mean, there's the median. Now what do you notice? Well, wait a second. This number right here, see him? He's really low. And what he's doing is he's causing the mean to get pulled much lower than it normally would be. Okay, so the mean is much smaller than the median because of that. It's called an outlier, right? He lies far out from the rest of the group, far away from the rest of the group. The median, however, resists that outlier, right? That number could have been 0. It would change if, for example, if you turn this to 0, it would change this number, but it would not change this number, right? This number is resistant. Here, let me, just for the fun of it, let me change it to 0. That turned the mean to 73, but the median stuck at 88. See? Okay. So the median resists that. Okay, well that's kind of a big deal. If the median is resistant, that means that if you have skewed data, which is actually at the bottom of this page, but if your data set is skewed, that means you're better off using the median, not the mean. For example, suppose we want to talk about the average salary of people in our class, and Bill Gates just happens to be one of our classmates. If that's the case, right, here's Bill Gates way over here. Well, to be honest, he's off screen, right? He's really high. But he causes our average, our mean, to become $20 million, which makes no sense, right? We don't make $20 million, but that's what our mean would be because he is so high, being, one of the wealthiest people in the world. Our median, on the other hand, would be, I just made this up, $22,000. That's much more realistic and appropriate for our data set. That's why at the bottom of the page, you'll see if it's skewed right, you use the median because the median is the more fair measure when it's skewed right. That's why when you listen to the Financial Times, they'll talk about the median income in America. They won't talk about the average income in America. They'll talk about the median income. And that's because the median is the more fair representation. Because to be quite honest, this is the way America looks. Very, very few people at the very, very top, but the vast majority of people are way down here. And it's not fair to use the mean. It's much more appropriate to use the median. By the way, the left edge over here is 0, right? Because you can't earn less than $0 in salary. Now you can be worth less than $0 net worth, but that's a different story. That's I owe debt. But this is talking about salaries for our classes. Therefore, the lower edge is 0. Okay? So the median is resistant to Bill Gates. Notice how the median doesn't get pulled around. The mean is not. The mean gets tugged towards the tail. Now, if it is skewed, right, then you'd be better off using the median, which is what I just mentioned before. So down here I have exam scores. So the right edge is 100 because you can't score higher than 100%, at least not on my tests. And then over here, 0, right? Students, when they get papers back, they're always like, what's the average? What's the average? And what they're asking for is the mean. But the problem with that is that most tests are like this, because you'll have the vast majority of the classes over here in the lump, and you'll have, one Yahoo that hasn't been there more than once and just shows up for the test and somehow thinks they're magically going to pass, right? So they will pull the tail towards them, and it causes the mean to get pulled down towards them. But the median resists that low score or low couple of scores and stays at the more appropriate value for the class. So when you ask your professors what's the average, what you really should be asking them is what's the median. That said, I bet most professors don't necessarily know how to find the median, but your math professors should, as should your stats professors, hopefully. Okay, so if it's skewed left, like this is, these test scores, that's skewed left. Got a tail going off to the left, the low numbers. Or if it's skewed right, this is this one, it's got a tail kind of going off to the high side, then you should use the median. The median's the more appropriate measure. Now you can tell if it's skewed left because the mean will be much lower than the median for skewed left, like this one, 62 to 82. And skewed right will be the mean is much higher than the median, i.e. like this one, 20 million to 22,000. Now a lot of data sets that we're going to work with pretty much from chapter 7 onward, it's the mean and the median are close. Now, this squiggly equals because how close is kind of a guessing game. These are only guidelines. This isn't exactly right, okay? But it only really works super well for continuous data, not for discrete data. And we'll talk about that in chapter 6 and 7. Remember, continuous is things that you measure, and discrete are things that you count. You learn those definitions in chapter 1. So in the long run, we're going to work with symmetric a lot more than anything else. But we're not ready for it right now. We're going to start dealing in this chapter with just the differences between them. But in the last several chapters of this course, we will only work with symmetric because it works so nicely and prettily for us. All right, so now let's get to reading the computer output. So on your final exam and on some of your tests, you're going to have to be able to look at an output from a computer and explain what you're seeing, find numbers that you're looking for. And sometimes that's going to be easier than others. These tend to be pretty simple to follow. So I have here the units for exports. So, the US exports, for a recent year with 3 different programs. Now up here I have Excel, here I have StatCrunch, and down here I have another program that you're not going to own, but you're going to read the output a lot of. It's called Minitab. It's a really popular computer program. And I could throw in others as well. But these 3 are the 3 big ones that will hit the most in the course, and they will be on the final, as well as any other test, most likely. All right, so the first thing I've asked is, what are the units of the US exports? And that should be rather obvious to you all. It's right here. It's billion dollars. Bold and underline. You can see it right there, $1 billion. You can see it right here, $1 billion. It shows it. Okay. How many countries were in the data set? N was, oopsie, hold on. You didn't need to, no. I hit control instead of, all right. N, there we go, is equal to 19 countries. That's a lowercase n, not a capital N. Lowercase n because it was from a sample. You can see it right here. Lowercase n is 19. Minitab is terrible about the difference between capitals and lowers, so it's 19. There you go. All right, what is the mean of this output? Let me pause this and I will circle and box these things for us in color so we can see it better. Hold on. There we go. I made it a little bit easier to follow here. So I highlighted it in purple. See that? $1 billion. And then down here, $1 billion right there in purple. And then there's the 19. And so it's right here. And it's right there in StatCrunch. And it's right there in Minitab. Now the mean is an X bar because this is really only a sample of all the US exports. We export to more than just 19 countries. So I highlighted that in green, and it's right here, 29.637 or so, right? Minitab doesn't give quite as many decimal places. That's all right. You got to work with what you got. And then the median, I put in blue. It's right here, 18.3 right there. It says median, 18.3, 18.3. Oops, I should probably have made that. There you go, so you can see it better. And this one doesn't call it n, it calls it count, but it works. Cool. Now, judging from the mean and the median, which you can see right here in green and blue, what appears to be the shape of the distribution? And the answer is it's skewed right, because the mean, which was 29.64, is much larger than the median, which was only 18.3. Okay. Now, if that's the case, then what's the best measure of central tendency? And the answer is the median, because the median is resistant to that skewing that we're seeing. We're seeing that it's skewed right, and once it's skewed right, you should use the median, not the mean, as your measure of central tendency, i.e. your average. So what's the average? You should say 18.3, not 29.64. All right, I'll see you back here for the mode for the last